Hi everyone, in this video we're going to be talking about how to find the x and y intercepts as another attribute of a polynomial. Remember, there are 6 parts to this series of attributes of polynomials, and x and y intercepts is just another thing, another characteristic of what makes a polynomial so special. So let's get to it. Possible x-intercepts. So when you're dealing with a polynomial, the degree, right, the highest exponent will tell you how many possible x-intercepts you can have. Let's think back to quadratics for a second, right? Let's stick to the basics for a little bit. When we have a quadratic, right, our general form is f of x equals ax squared plus bx plus c. Now, if we think about a quadratic, you have several possibilities. A parabola can have 2 x-intercepts, here and here. A parabola can have 1 x-intercept, here, or maybe it has none. And it doesn't cross the x-axis at all. Because we're dealing with an exponent of x squared, right? The function is x squared. I know that it can have up to 2 different x-intercepts. Now, maybe it has less, maybe it has none. But the maximum amount of x-intercepts that it can have is the highest degree of the exponent, right? So, as an example, if we're dealing with a polynomial that looks like this, the highest exponent that we're dealing with here is to the 5th power. This is the degree of the polynomial. Therefore, the maximum amount of x-intercepts possible is 5. Maybe it has less. Maybe it has none, right? But the maximum amount that it can have is 5. Actually, because it's an odd exponent, it will have to have 1 x-intercept at least. But it can go anywhere from 1 all the way to 5. Okay, not more than 5 x-intercepts. For now, knowing the exponent will tell you how many possible x-intercepts it can maximum have in a polynomial. So how do we find the x-intercepts? Later I will show you how to do this by hand. I will show you different methods on how do you factor something that's x to the 3rd power or to the 4th or to the 5th or something like that. For now, all we're going to be dealing with is you're going to be going to Desmos, graphing your polynomial, whatever that polynomial is, and just go to the x-axis and identify the x-intercepts. Here, 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 and here. Right? To identify it, you would simply go and locate those points on the x-axis. And you do that by going to Desmos. Now, there's different names for x-intercepts, right? We can be dealing with roots. We could be talking about zeros. We could be talking about solutions. There's a lot of different names for x-intercepts, but for now, click on the graph, identify those key points where it crosses the x-axis, and you can see the points written as something like this. X, comma, 0. X, comma, 0. Those are going to be your x-intercepts, right? And depending on the polynomial, the more x-intercepts are possible. So for now, Desmos. Later, I'll show you how to do this by hand. Y-intercepts. Well, similar to Desmos, right? You can always graph it and just check the graph and see where it crosses. So depending on your polynomial, you'll put it in the graph, you put it on Desmos, and you can identify on the polynomial what is my y-intercept. Now, the y-intercept will cross the y-axis. Okay? And what we will always know about the y-intercept is that the x value is always 0. Because it lands on the origin, where x is 0. And we just want to figure out where does it cross the y-axis. You can do that on the graph, zooming in, zooming out, identifying that location, or you can even do this by hand, and I'm going to show you how to do that real quick. Okay? But a thing that we want to know is is that x value is always 0 for the y-intercept because it lands right on the y-axis. Since we know that it lands on the y-axis and that x is always 0, I'm going to start with that. So let's say that we have a polynomial. Let's say that we have some sort of polynomial that looks like this. F of x equals 3x to the third power minus 4x squared plus 7x plus 2, right? If I know x equals 0, what I'm going to do is I'm going to plug in the 0 for every x value that I see. Anywhere you see an x in the function, I'm going to plug in 0 and evaluate this function. So I have this. F of x equals 3, 0 to the third power, minus 4, 0 squared, plus 7 times 0 plus 2. Anything to 0 to any power will always be 0. So this is technically just 0 to the third power, which is 0. 0 times 3 cancels out and gives you 0. Same thing with the next notation. 0 squared is 0 times negative 4 is also 0. 7 times 0 is still 0. What am I left with? 2. So really my function is f of x equals 0 plus 0 plus 0 plus 2. So the y-intercept is 2. Okay? Simply 2. Anything that you plug in for 0 was going to cancel out for the x values, leaving you with a number at the very end, the y-intercept. So let's say we have another function. Let's say that the function looks like this. F of x equals negative 7x to the fifth plus 3x fourth minus x squared plus 10x minus 1. If I'm going to be plugging 0 for all the x values, right, I'm going to plug in a 0 here, a 0 here, a 0 here, and a 0 here. This is going to cancel, 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 leaving you always with this last number. That's always going to end up being your y-intercept. Always, every single time. Because all of the x's, when you plug 0 in, are going to cancel, leaving you with the number at the very end. So if we look at the most general form, right, let's just look at the very general notation. F of x equals ax to some power plus bx to some other power plus cx to some other power. As these numbers keep decreasing, eventually you're going to have a plus d, or a number that does not have an x value. Everything is always going to cancel. All right, cancels. Cancel, cancel, cancel. Everything's going to cancel except for the last value. And that last value, as long as all the like terms are combined, the last value that does not have an x will always be your y-intercept. So if your function doesn't even have a number at the very end, it means that it's going to be a plus 0, leaving you with 0 as your y-intercept. Here's another example. I'll see if I can squeeze one in here as well. Let's say that we're dealing with f of x equals 7x cubed plus 5x squared plus 10x. If I plug in 0 for the values that I said, 0, 0, 0. What's my y-intercept going to be? 0 plus 0 plus 0. My y-intercept, I'll change colors again. My y-intercept here is 0 because everything got canceled. 0 plus 0 plus 0 gives you 0. All right. This is a quick shortcut that will help you identify. You can always use decimals for x and y intercepts, but I figured sometimes it's even faster to identify the y-intercept by simply plugging in a 0 and identifying it from the function. I hope this helps. Please let me know if y'all need anything. Don't forget to like and subscribe if you haven't already. And as always, we'll calculate later.